These mobile charging devices are the simplest way to charge an electric car. My name is Janos, I've built my own electric cars, and my first port of call when I needed to charge it was to figure out how to release energy out of these ones. Currently, these pins aren't live, but if you set the right signals here and here, you're going to be able to release the energy and charge your electric car. Alright, let's go inside and I'll show you the wiring diagram. The key to these AC chargers is really their simplicity. If you look at a rapid charger, there's power line communication going on, there are digital messages sent back and forth. The AC charger that we just looked at is really much simpler. There's a single waveform, and that single waveform encodes everything you need to know. Is a car plugged in? How much power is available, and is the car charging right now? And everything is analog, right? There's no digital messages being sent. So the key really here is the simplicity of this. Okay, so let's look at the circuit now. On the charger side, you've got an oscillation between plus 12 volt and minus 12 volt. Then you've got a known resistor and a known capacitor. And then the charger can measure itself over here. On the vehicle side, you've got a diode and a known resistor as well. And then a measuring pin for the vehicle to measure as well. If you just turn the charger on and nothing is connected, you will measure 12 volt, steady 12 volt on that pin and nothing else, right? As soon as the car is connected, the car will see 12 volt and then it will drop down like instantaneously really to 9 or 6 volt depending on the resistor that you've got there. Now both the car knows that it's plugged into a charger and the charger knows that a car is plugged in, right? So the charger can now open the power lines and the car will look at the duty cycle of the waveform to figure out how much power it's allowed to draw. The duty cycle is quite simply how long is it on versus how long is it off. So here is how it would look with the low duty cycle, here's how it would look with the high duty cycle. And that is it. Now you know how through that one little circuit, every AC charger everywhere detects if a car is present or not. So to recap, you've got the little pin here, it reads 12 volts when nothing is plugged in. There's an oscillation in the charger side, the car's got a known resistor and a diode, and from the duty cycle, the car can figure out how much power it's allowed to draw. There's a little bonus thing here where someone asked me, oh, could you build me a AC charger that shows in a big display the state of charge of the car that's plugged in? And the answer to that is an emphatic no, because the charger doesn't even know that. What you could do is you build an AC charger that shows you how many kilowatt hours were delivered since something has been plugged in, like in this session. And from this, someone could work out if this is the beginning or the end of the charge cycle and if it's still charging. So the charger doesn't know the state of charge of the batteries. Okay, and this is how your charger detects if a car is present or not. I hope this was helpful. If you're looking to learn similar things like this, check out my app. Go to foxev.io/academy and learn more about electric cars and how they're really put together.